Bismillahirrahmanirrahim. Hello and welcome to Rahman Digital Production. This is lecture number 52 of Physics 5054, and today we are going to start unit number 9, and that is the simple kinetic theory of matter. This is very important topic in this unit, and in the few next unit we will talk about this theory very frequently. Ladies and gentlemen, this is given on your book on page number 130, and in this unit we will develop a molecular model for matter. We will discuss that how every matter is made up of atoms and molecules. Then on the basis of that theory we will develop a concept to describe different states of the matter, that is solid, liquid and gases. And we will also develop a concept which will tell us how the state change can occur. For example, we will say how melting of ice is occurring and how liquids are changing into steams. These questions were hidden questions for a very long time, and scientists were trying to develop this concept. For that particular purpose, Robert Brown, an Englishman, did an experiment and he explained this model, the kinetic theory of matter. What is matter? Matter is anything which occupies space. One thing. What is kinetic? Kinetic means motion. Anything who is having the capability of motion will have kinetic energy. So what does it mean? Kinetic, the movement in the matter of what? Of molecules. So, on the basis of this theory, we will first explain three states of matter. Ladies and gentlemen, keep in mind that so far there are 7 to 8 different states of matter being invented, but we are sticking only to those states which are included in this basic level course. They are solid, they are liquid, and they are gases. If we are explaining these three states on the basis of this simple kinetic theory of matter, we will remain in the context of that theory and will explain the solid. Without this theory, it wasn't possible to explain these three states. Let us discuss it. First is the solid. Solids are having fixed shape. If you are putting it in a container, it will remain the same. For example, if you are putting a metal cube inside a tin, it will remain the same. A very large force is required to change the shape of solid. Easily or automatically, it cannot be changed uh, from one shape to another shape. So solids are having fixed shape and fixed volume. If it is not changeable, then it means that its shape, its volume will also remain the same. It will not expand to every corner of the container. So that is why we are having fixed shape and fixed volume, which are normally hard and rigid. Solids are normally hard. For example, this whiteboard is hard. If we want to compress it, very large force is required. If you are putting this whiteboard inside the room or outside in the corridor, then it will remain the same. Its volume and its shape will remain the same. Large force required to change its shape. Large force requires to change its shape. That is what I told you. Solids are having high density, yes, because they are closely packed together, so they are having high density. High density means that mass per unit volumes will be more as compared to this shape. They are closely packed, so their density is much higher than this. In comparison, the density of this model is higher than this model. We will discuss that in a moment in greater detail, but let me tell you that shape solid are having high density, and one more important thing is and are usually incompressible. There is a wall, and if I want to press this wall, it is not compressible. But if we are considering this gas, so it can be compressed. Solid and liquids are not compressible. That is why these liquids are used in hydraulic brake systems, because it cannot be compressed. So that is why they are used in the hydraulic brake systems, and we discussed that in the previous one lecture. Okay, next one is liquids. What are the properties of liquids? Liquids are having fixed shape just like the solids. It is having fixed shape. Solids are having fixed volume, but liquid doesn't possess fixed volume, because when you are putting a liquid inside a glass, it will retain the shape of the glass. If you are putting it inside a beaker, it will take the shape of a beaker. If you are using it in the test tube, it will get the shape of test tube. So it is not having a fixed volume. They are having high density, just like this. Water is also having, but they are not in a regular shape manner. While liquids are having high density and they are incompressible, as I told you that they are incompressible. In the similar fashion, we are going to discuss gases. They have no fixed shape. Yes, if you are having gas in the air. Air is the mixture of different gases. In air, there is a gas. You can't say that the shape of the air is a particular one. No, it is not having a fixed shape as well as a fixed volume. So they have no fixed shape and volume. Gases are having low density, they are not that much dense, and they are also compressible. Yes, gases can be compressed. Ladies and gentlemen, one very important uh, other state of the matter is, and that is plasma. But we are not going to talk plasma about the highly ionized form of a matter is called plasma. For your information, if you are putting plasma inside a container, you can't say that plasma is in this part or it is occupying the full space inside the plasma. Why it erodes the concept of plasma? Because the heat, light coming from the sun was not explained on the basis of these properties. So there was a need of another property which is plasma. We are not going to discuss that, but for the time being you should keep that there is a fourth very important, and very soon in next class you will learn about the plasma. Next topic is the kinetic molecular model of matter. What does it mean? It means that every matter consists of atoms or molecules, and those molecules are in random and continuous motion inside the matter. That is called the kinetic molecular model of matter. This model of matter describes matter is being made up of molecules in continuous, they can never be stopped. Random, haphazardly, it is moving in one direction and another direction. Well, the theory is available, but it wasn't explained until Robert Brown did this experiment and explained it that yes, we can explain the solids, the liquids, and the gases on the basis of this simple kinetic theory of matter. Ladies and gentlemen, let us discuss the internal structure of solids, liquids, and gases. This is the state of matter, and we are discussing this state of matter. Ladies and gentlemen, in the first case, the arrangement of molecules in a very regular order. If you are seeing it from this perspective, it will be in a straight line. If you are seeing it from this side, or from this side, or from this side, or this side, or this side, they are having a very regular shape. They are having a very regular shape inside the matter. And one thing more you can observe, that they are closely packed. That is why solids are occupying less space. And thanks to the kinetic molecular model of matter, that we can explain these things very easily. So what is the arrangement of particle inside the solid? We are having, this is the solids. So closely packed and regular pattern, that is a very regular pattern. There was a subject in the master degree we studied, that was crystallography. Because my specialization was in solid state physics, so I studied crystallography in greater detail, and crystal are also having very precise pattern when we are studying internally through a high resolving microscope. The same case is in the solid. They are closely packed together. Why? They occupy minimum space. So that is why they are occupying a minimum space. What is the movement? That is the generalization of this pattern. But internally, what important role this kinetic theory of matter is playing in the explanation of solid state? The molecular movement is vibrating about a fixed position. They are vibrating like this. There is a fixed position and they are having to and fro motion. Nothing in this universe is in stationary state. This is a very famous theory of physics. Nothing in this universe is stationary. So we are saying this wall is stationary. No, when we study internally with the high resolving microscope, the internal structure, we will find that the atoms or molecules are vibrating about the fixed point. If you are reducing the temperature, the movement is reducing, but it is not stationary. Keep this in mind. One day you will understand. Now, the second part is liquid. The structure of molecules inside the liquids are in the form of clusters. This is a cluster, this is a cluster, this is a cluster, and this is a cluster. They are not that much closely packed as compared to the solids. So ladies and gentlemen, keep in mind that it occurs in clusters. These are the different clusters which are rolling one over another. And that is why when we spilt the water on the floor, it is rolling, because the molecules are rolling on one another. So occur in cluster with the molecules slightly further apart as compared to this model. The molecules are slightly further apart. What is the role of molecular theory? Free to move about between cluster. Yes, you cannot bound these molecules to be confined, to be forcefully move around a fixed position as in the case of the solid. So free to move about they are free to move about between cluster but confined within the vessel. It will remain in the vessel. It will not jump out from the vessel containing it. What? The solid. Sorry, the liquid. Where the liquid is containing, it will remain inside the container. Now, the third one is gas. Gases. Okay, very far apart from one another, the molecules. And they are occupying more space. Closely packed, a little bit apart, very far apart. So it is written here very far apart and occupy available space. Whatever space they are getting, if you are putting it in a vessel, it will occupy the full space, just like I mentioned the plasma as well. It will occupy the whole space. You cannot say that plasma is confined to this part of the container. No, it is occupying the full space, just like the gases are occupying the full space. Now, the movement of molecules inside the gases is having high speed independent motion in random manner. They are randomly moving. One is moving like this, then it is moving in this direction, then it is in this direction, this is in. So the molecules are moving randomly and they are striking with each other, putting pressure on each other and on the walls of the container. They are also putting pressure on the walls of the container. So there is a haphazard motion amongst the molecules, random motion, independent of one another. When they strike with each other, they are deflecting on a certain angle. Ladies and gentlemen, in the master degree, my project was on the hot electron behavior in semiconductors using Monte Carlo method. That is a special method. I use a Fortran program to trace the path of electron, and when it was striking with another electron, at which angle they were deflecting, that was the total phenomena of my project. What was the mobility, velocity at different position? So it is possible. Okay, the next topic is people are explaining these things, but nobody confirmed that this is the motion of atom, because atom is a very very small thing. It cannot be seen even with a very high resolving microscope. So how can a person say that molecules are moving randomly? Robert Brown, an Englishman, performed an experiment. There was a light source in his experiment, and through this experiment, he was able to see the motion of molecules, and that is called Brownian motion. What is Brownian motion? The haphazard or random motion of molecules in the matter is called Brownian motion. Now, how can we explain this on the basis of these kinetic model? He performed this experiment. There is a light source which was going from a slit and then passing through the converging lens, and that converging lens is doing what? Focusing the light source at a particular spot. Why? Because we wanted to see the smoke particle inside this container. This is glass smoke cell or chamber in which is sealed from here, which is sealed from here, and there is a little smoke inside this cell which is placed under the microscope. This is the microscope. This microscope is being able to see the motion of this smoke particle. But one question is there, that we are seeing the smoke particle. These are not the atoms or molecules. Yes, but these smoke particles are made up of atom or molecules, and they are bombarded by the atom or molecules of the air, and as a result they are spreading in different directions. We cannot see the atoms or molecules visually, but through these smoke particles which we can see under the microscope is telling us that these smoke particles are moving in the container randomly, because there are air molecules, and those air molecules are hitting the smoke particle, and we can observe those smoke particle, and we can conclude that every matter is consist of what? Every matter is consist of molecules. So motion of the molecules can be explained with the help of this Brownian motion. If somebody is asking the definition of Brownian motion, you can say that the random motion of molecules inside the matter is called Brownian motion, and it is named after the English scientist Robert Brown, and he observed that somewhere in 1827. He observed that in 1827. Ladies and gentlemen, motion is independent. The next topic we are having and we have to explain is motion of molecules and temperature. Motion of molecules and temperature means that what is the relation between motion of molecules and motion and temperature. When we increase the temperature, the agitation is more inside the molecules. They are agitated rigorously, they are moving in all the direction, because we are providing energy to each and every molecule by increasing the temperature. So it can affect the motion. Temperature can affect the motion of molecules and atom inside the matter. In fact, we can increase the speed of these molecules with the increase of temperature, and similarly we can decrease the motion of the molecules with the decrease of temperature. If we are cooling a matter, then the motion will have less speed as compared to the motion when it is having the high temperature. Ladies and gentlemen, our next topic which we will discuss tomorrow is pressure in gases, and that is also very important phenomena, that how gases inflating the tires, the tubes of a car. We will discuss that in greater detail. So be in touch. Don't miss the next topic, because we started another scenario of physics. 2 or 3 units will lead us to the different conclusion. Thank you very much for watching. Allah Hafiz.